Welcome you all. Today we are going to see about optimal page replacement algorithm, which one is the most important concept in memory management technique in operating system. Before that, you subscribe this Charan Media's channel and click the bell button for the future notification. Let us start. First we will see about the optimal page replacement algorithm and its advantages. Generally, optimal page replacement algorithm has the lowest page fault rate of all algorithms. From this we can note that when compared to all other algorithms, optimal page replacement algorithm has the lowest page fault. In optimal page replacement algorithm, the technique followed is replacing a page that will not be used for longest period of time. This optimal page replacement algorithm is difficult to implement because it requires feature knowledge of the reference string. This algorithm is mainly used for comparison studies. Next, we will see about the optimal page replacement algorithm with an example problem. Here, one example problem is given. 20 pages are given for the execution. They told that we have to take only 3 frames to store. At starting level, the frames are empty. Let us solve. Here, first page we want to execute is 7. The memory is empty, so we will insert the 7 into the memory for the execution. The next page we want to execute is 0. Already we have 2 pages, that is free frames, so we will insert and we can execute. Next page we want to execute is 1. We have 1 free frame, so we also insert 1 into the memory for the execution. Up to now, the 3 pages are stored in the memory and they are executed. Now the next page we want to execute is 2. The problem arises because already we have 3 pages, so we want to replace one page. Here we are going to use optimal page replacement algorithm. Already we have 3 pages, so we want to execute the page 2 by replacing these 3 pages. 7, 0, 1 are the 3 pages in the memory. So here by using optimal page replacement algorithm, we have to look for the page which will not be used for the longest period of time. So see the sequence. After this 2, 0. So 0 is going to use. After that 1 is also going to use. So at last 7 is going to use. So we have to replace the 7 by 2. Next the page want to execute is 0. The page is already present in the memory, so there is no page fault occurs. So we go for the next page. The next page is 3. So we have to replace 201 which is in the frames. There can be replaced with 3. So we have to see in the future analysis. So next 0 is going to execute. After that 2 going to execute. So we have to replace 1 by 3. The next page we want to execute is 0. This 0 is also the present in the memory, so there is no page fault occurs. Next we go for the next page. Next page we want to execute is 4. So 4 is replaced with out of these 3 pages 203. So see the future reference. 2 is going to execute next. After that 3. So we have to replace 0 with 4. So we will get the output as 243. The next page we want to execute is 2. The 2 is already present in the memory. Next page 3. 3 is also present in the memory. So there is no page fault. So next we go for the 0. Next page we want to execute is 0. Already we have 3 pages in the frames 2, 4, 3. So we have to replace any one page with 0. So we have to look for the future reference. See the pages after the 0. So next 3 we want to execute is 3. Next we want to execute is 2. So the page will not be used for the longest period of time is 4. So we have to replace 4 by 0. The next page we want to execute is 3. 3 is already present in the memory, so there is no page fault. The next page we want to execute is 2. 2 is also present. So we have the pages in the memory is 203. The next page we want to execute is 1. So we have to replace out of these 3 pages. See the feature reference. Next page we want to execute is 2. Next page we want to execute is 0. So we have to replace 3 by 1. We get the output as 201. 1. The next page we want to execute is 2. The 2 is already present in the memory, so there is no page fault. Next we want to execute is 0. It is also present in the memory, so there is no page fault. Next page we want to execute is 1. This is also in the memory, so no page fault. Next page we want to execute is 7. So 7 is replaced with any of these 3 pages, 2, 0, 1. So let us see the feature. Next 2 pages are 0 and 1. So we have to replace 2 with 7. The process is completed because next 0 and 1 is also in the memory, so we can execute easily. By solving this method, we have to complete the process and we have to count the number of page faults. After counting, we get the output as 9 page faults.